Our next algorithm thinks in a completely different way, with probability, not geometry. It's called naive Bayes, and you've almost certainly benefited from it. For years, it was the engine behind email spam filters. Let's build one. Here's an email. You're a winner. Claim your free prize. Is it spam? Or a real message? Naive Bayes doesn't guess. It weighs the evidence, word by word. It asks, which is more probable, spam or not spam? We start with the base rate, how common each class is to begin with. Say roughly 3 in 10 emails are spam. That's our starting belief, before reading a single word. This is called the prior. Now each word carries evidence. From past emails, we've learned how often each word shows up in spam versus normal mail. The word free is very common in spam, and rare in real email. Same with winner and prize. Each of these words tilts us toward spam. To combine the words, naive Bayes makes one bold, simplifying assumption. It treats every word as independent, as if seeing free tells you nothing about seeing prize. That lets us just multiply the word probabilities together. This shortcut is exactly why it's called naive. So for each class, we multiply the prior by every word's probability. For spam, all those spammy words are common, so the numbers stay high. For normal mail, those same words are rare, so the score collapses toward 0. Finally, we compare the two scores. Whichever is larger wins. Here, the spam score towers over the normal mail score. So naive Bayes confidently files this email as spam. Now, is that independence assumption actually true? Not really. Free and prize clearly travel together. They're not independent at all. And yet, even with that wrong assumption, naive Bayes works remarkably well in practice. Sometimes a simple, slightly wrong model is all you need. Naive Bayes has real charms. It's blazing fast, it needs very little data, and it handles thousands of features, like words, with ease. That makes it a superb baseline, especially for text, spam, topic labeling, sentiment. Its main limit is that bold independence assumption, and shaky probability estimates. In scikit-learn there's a naive Bayes for each kind of feature. Multinomial NB is the classic for word counts, Gaussian NB is for numeric features. The pattern is the same as always. Import, fit, predict. So naive Bayes classifies with probability. Start from a prior, multiply the evidence from each feature, and pick the most likely class. It's naive, it's fast, and it's a fantastic baseline for text. We've now met 7 algorithms. Next, we learn how to choose between them.